In mathematical logic, I already discussed propositional logic, then propositional equivalence, quantifier and nested quantifier. Next I will discuss rule of inference. Set of propositions called as argument. Like we already know, in case of implication, P implies Q, P called as premises and Q called as conclusion. Here we have more than one proposition like P1, P2 up to Pn. We have n proposition and from that we will derive the conclusion, and this is called as argument. So an argument is valid if the truth value of all its premises implies that the conclusion is true. If all this truth value implies conclusion is true, then we call as this argument is valid. An argument form is valid, the conclusion is true if premises are all true. Means if Q true means all premises are true, then that argument form is valid. The argument form with the premises let P1, P2 up to Pn, and the conclusion Q is valid when P1 and P2 up to Pn implies Q is a tautology, means all truth value are true. We follow some rules to establish the validity in argument, that's called as rule of inference. We have set of rule of inference that will follow and will check validity of an argument. The rule of inference can be used as a building block to construct some complicated valid argument form, so that we can use to check whether one argument is valid or not. The tautology P and P implies Q, whole implies Q is the basic of the rule of inference called as modus ponens or the law of detachment. That we can write in form of rule of inference as P, then P implies Q. If P is true, P implies Q is true, then Q is true. This symbol is for therefore. In case of P implies Q, if P is true, then Q must be true. If Q will be false, then P implies Q will be false. So here this means P implies Q is true, P is true, then Q must be true. Let's see one example. Suppose that the conditional statement, if it snows today, then we'll go skiing, and its hypothesis, it is snowing today, are true. Then by modus ponens, it follow the conclusion of the conditional statement, we'll go skiing is true. Let if it snows today is P and we'll go for skiing is Q. So P implies Q is true and it is snowing today, P is true. So P implies Q is true, P is true. That means Q will be true. Q is what? We'll go for skiing. So we'll go for skiing is true. Let's discuss some rule of inference. Table 1, rule of inference. These are the rule of inference. Here are the tautology and the name of the rule of inference. First is modus ponens. If P is true, P implies Q is true, then Q must be true. In tautology form, P and P implies Q, whole implies Q. This should be tautology. All truth value is true. Next, modus tollens. If negation Q is true, negation Q is true means Q is false. If Q is false and P implies Q is true, P implies Q is true and Q value is false, means P should be false. P value is false means negation P is true. So that is our modus tollens. In tautology format we can write negation Q and P implies Q, whole implies negation P. So if Q is false, P implies Q is true, then P must be false. P must be false means negation P is true. Next, hypothetical syllogism. If P implies Q is true, Q implies R is true, then P implies R is true. So that we can write as P implies Q and Q implies R, whole implies P implies R. Next, destructive syllogism. P or Q is true. We know in case of OR, if P is false, Q is false, then it will be false, otherwise it is true. If at least one is true, it will be true. And here it's given negation P is true. Negation P is true means P value is false. If P value is false, then Q must be true. That's why P or Q is true. So when P or Q is true, negation P is true means P is false, then Q should be true. That we can write in tautology format, P or Q and negation P whole implies Q. Next, addition. If P is true, then P or Q is true. If P is true, then P or Q, whatever the Q value, whether it is true or false, if P is true, true or true will be true, true or false will be true. So in case of OR, if 1 is true, then it will be true. Even if Q will be true, then P or Q will be true. So that's the addition rule. Next is simplification. If P and Q is true. In case of AND, it will be true if both are true. So if P and Q is true, then P is true. Even you can write Q is true. If AND is true means P is true and Q is true. That we can write as P and Q implies P. Next is conjunction. If P is true, Q is true, then P and Q is true. In case of conjunction, if both are true, then P and Q will be true, else it is false. So if P is true, Q is true, then P and Q is true. That we can write in tautology format as P and Q whole implies P and Q. Next is resolution. If P or Q is true, negation P or R is true, then Q or R is true. I'll discuss resolution in detail in next lecture. Let's see one example. Example 2. State which rule of inference is the basic of the following argument. It is below freezing now. Therefore, it is either below freezing or raining now. Let P is, it is below freezing now, and Q, it is raining now. So you can write P means first statement, it is below freezing now. Therefore, it is either below freezing or raining now. So that we can write as P or Q. So P is true. Thereafter, P or Q is true. And this follows addition rule. So rule of inference is addition that we follow here. If P is true means P or Q is true. Here P is, it is below freezing, and P or Q is, it is either below freezing or raining. You need to remember all the rule of inference. We'll use all the rule of inference to check the argument validity. In next lecture, I will discuss some more example of checking validity of an argument. If today's lecture is helpful for you, please like, share and subscribe. Thank you.